Today, what we will do is we'll take a look at what is subquery and why subquery needs to be used and when to use it and how to use it. And also, we'll take a look at what is the difference between subquery and correlated subquery. And last but not the least, we'll take a look at the limitations of subquery. Okay. So first of all, what is a subquery? A query inside another query. Okay. A query embedded in another query is called your subquery. The subqueries are not specific to SQL Server. It is very common to all the RDBMS system. It allows us to use the result of one query as a result of another query. For that purpose, we'll be using the subquery. So this is the kind of situation we'll be using it. And subqueries, you can use it anywhere in your SQL statement. For example, you want to use this, the another SQL query as part of a select list, that is possible. You can use subquery as part of from clause and where clause and having clauses also, okay? I just show you a few examples for that. For example, in this case, this is a syntax, select class, and followed by this, we have column 1, column 2, and followed by the from class, we can see the table name, and followed by from class, we have where class. In the where class, you need to specify the column name, and in, there's something called in class, followed by that. You can see that we have used the subquery. This is subquery here, okay? 1 second, let me just check. So this is the subquery. This is the subquery. So in this case, we have used this subquery in the where class. And similarly, we have another example for the subquery. In this case, I have used, you can use the subquery followed by the from class itself. Okay. And even in the join class also, you can use the subquery. And apart from this, in the select class itself, you can use a subquery. Look here, this is your select class. Here itself, we have used another subquery. As you know, so usually followed by the select statement, we specify column 1, column 2. In this case, column 2, I have taken it from another table. Okay, so we can use a subquery in your where class, and you can use a subquery in your from class, and even in the join class, you can use it. And also in the select class itself, you can use the subquery. There are two different types of subquery at a high level. One is the subquery, the plain subquery, and the other one is the correlated subquery. So here is, the as part of the subquery itself, right? There are three different types of subqueries. Other one is the scalar subquery, and the other one is the multi-row subquery, and the next one is the nested subquery. I think you have watched my video, right? This is the thing I discussed it in my video also. Not much difference, because these are the common concept. And here, in this case, for example, for the scalar subquery, what we'll do is I'll just connect to the SQL server. Yeah, I already connect. So here is the SQL server. I'm going SSMS, and I'm going to hit the connect button here. So let us wait for some time. The next databases will expand this one. So in the databases, we can see a lot of things here, right? We can see a lot of databases created. So we will work on a specific database, okay? Instead of working on, but make sure that you're not using the system database, okay? To start with, we'll explore the subquery now, the plain subquery. What I will do is I'll just connect to the demo database. Here, let me just check the tables with the employee and no, not this one. Let me use something, a demo database too. Yeah, so here we have, so I'm going to click on the new query. So we have various databases are there. I'm going to use the demo database now. We need to tell SQL Server which database we need to use it. Use demo database and go. Okay, and here what I do is I just, for example, yeah, I just want to select to start with. Let us see what data is there in the employee table. So I have selected everything. I'm going to press F5, or you can click on the execute button here. For example, you can select everything. You can click on the execute button here. The other alternatives, best thing is you can select everything, Control E, F5. So now we can see, these are the columns are available in this table. The next thing is I will show you how to select, how to use a subquery in the where class. Okay. For example, we want to find out the employees whose salary is greater than the average salary drawn by the total employees. So in our case, we have 14 rows are there in this case. Look here on the right side bottom, you can see 14 rows. So which means 14 employees are there. So find out the total, the average salary for this, all these employees. And once you find out the average salary for all the employees, which you give it, next step is we need to find out those employees are getting more salary than the average salary of all the employees. Okay. So how do I do that? How do I do that? I'll just write the problem statement. Display all the employees whose salary is more than the average salary of all the employees. And here, so what do we do? For example, we will first check what is the average salary of the total employees. Here we have the column by the name of salary and from employee. Okay, I just do this and press F5. So this is the average salary, 1930. How much we see here? I will just put it followed by the comment here. I'll just note it down here, 1930352. So this is the average salary of all the employees. Okay. 1 second, please. Somebody is knocking at the door. Delivery person. 1 second, please. I got some courier. Just give me. Sorry, I'm back now. So these guys, the delivery guys, they come just like. Okay. So this is the average salary. So now what we need to do is we want to find out all those employees whose salary is more than this average salary. Okay, of all the employees. Okay. So how do I do that? I need to display the employee name. Okay, here or let's say select star from employee and where what we want to select, find out the salary, right? So where salary is greater than greater than 1830. Okay, we can say this way. Press F5. Yes, we can see that salary, five employees salaries are more than the average salary of the all the employees of the company, right? So the 1830, obviously these values are more than this one. But this way, we can do it. We can find out, we can get the solution for this problem statement, but this is not the right way of doing it. Why? Because here I have odd coded the value. What if 100 more employees are joining my company after a week? What is going to happen? The data will change. Obviously, the average value will also change, right? So when you include additional 100 employees, obviously the 100 employees salary will vary from person to person. So that may leads to increase in salary, or there will be some kind of variation. Average will not remain same. So is there any way, if I can write a query in such a way, even if any new employee get joined in my company, it should automatically find out the average. 1 second. Find the average salary. So how do I do that? So what I'm going to do is I just use the same query in this subquery. Okay, I'm going to use the same query in the subquery. What is this subquery here? This query this query will return only one row. This query returns only one row. In the where class, I just use it inside the parenthesis. Okay, and I'm going to say go here. Here, just select this. So note down the 5 employees. These employees, right? Jones, Blake, Clark, and Scott, and Ford. I'm going to execute this query. James, Blake, Clark, Scott. Yeah, the same guys. So this query also returns the same output. Even this query also returns the same output, but this query is very dynamic. Even if you add 100, or even if you add 1 lakh employees, probably after a week or after a month, this query will work. It will automatically, right? So even if at that point for example, at the time of executing the query, what are the data that are there in your table, it will find out the average salary for that. And then this query will get executed first. This is called your subquery. This subquery will get executed first. This subquery is also called as a scalar subquery. Why it is called scalar? What do you mean by scalar? Did you all watch my SQL query video? So what is scalar? What is scalar? How many of you watched my SQL videos? It's all very simple, guys. Watch my videos. That is more than 7. If you say I watched your videos and I got cleared with everything, then we can proceed with interview, right? Right. So here the average. So this one returns only one record, only one value. Since it returns only one value, it is called scalar, right? The only single value is called scalar. Remember this. This is common in any programming language. Scalar is nothing but a single value. And since this query returns a single value, it is called scalar subquery. Why it is called a subquery? This is your subquery or inner query. Okay, sorry. Let me just this is my subquery, and this is called your outer query. The select star from employee have this outer query. This is your inner query or subquery. In this case, this subquery is called a scalar subquery because it returns only one value, which is nothing but 1830, right? This query returns this value. since we have used this query itself, as a subquery here, so at the time of executing the query against your table, whatever the data that are present at this point in time, it will find out the average salary, and then this query's output will drive the outer query. So select star from employee where salary is greater than 1830. So yes, Raji, you are correct. So this query will be executed only once. Okay, executed only once. The output of this query will be, which is nothing but 1830 and odd, right? That one will be used as a, that value will be used to filter this employee table. That's all. Okay. This is called your scalar subquery. Okay. And one second. Okay, next one is the multi-row subquery. Okay, we will see what is multi-row subquery. Yeah, we will see to that. Okay, we will go step by step. Okay, your question is there any other way I can find out the average salary? Yes, we have different ways of finding out this, salary. And okay, I'll give you another example. For example, you want to find out the employees whose salary is more than the average salary of or more than the salary of a specific person. Okay, or what we'll do is yeah, I'll just write this query. What can we do now? So we will try some other thing here. For example, your question is, okay, in a specific department, right? Yeah, she wants to know in a specific department, those employees' salaries, average salaries, find out, and then, those list out all the employees whose salaries greater than that specific department's average salary. So all you need to do is just simply copy paste this one. Is this what your question, right? Employee, and we have something called and option, and depart number is equivalent to let's say you have something like 30, right? 30. Okay. The department 30, what is the average salary? So here we can see that the salary is 2,850. So now we need to understand what is the average salary in the depart number 30, which is okay. Here actually what we do is and depart number 30. Sorry, where depart number equal to 30. 1590. And if I execute this one, look here, 1590, more than 1590, these are the salary. If you want to find out the average salary of a specific department, and then you want to use that as a filtering value to drive your outer query. So you can use this one also, okay? Yes, we can find out the average salary using join condition also. For example, you have something like join, we will see it a little later. Okay, select any of, since you've asked this question, we will see what are the other options that we can use it to find out the average salary of the employee from employee. Okay, from, I'm going to say employee table, followed by the from clause, you need to specify your employee table. And I'm going to specify E, followed by the employee, I just specified the E. This E is nothing but alias, the short name, okay, the join. I'm going to use the join statement. And I have another requirement, select, average of E2 dot salary from the same table employee. I'm going to call it as a E2, the alias name, okay, as average salary. on E dot salary is less than the average or greater than, okay, the greater than average salary here. Mm, line 27. So there is a problem here, right? Average salary. Okay, here, see, look here. In this case, I did not specify any alias, right? See, whenever you use any aggregation function like average, sum, min, max, what you do is, right, followed by that, you give some alias, okay, ABG or something like that, okay? So average salary, space ABG. Yes, yes, I'll explain it, don't worry, okay. On this one, I just, okay, employee table. Join, select average of E2 dot salary as average from employee to, yeah, here, this is a subquery I've used. See, in this, now, we have used this subquery in our join class, okay? On E dot salary, this is E dot salary is average sal dot AVG. It's correct only. Instead of using AVG as a function, what I'll do is I'll use sal1. Okay? The spelling mistake here, the employee, it is supposed to be employee. Otherwise, employee. So this one also gives me the 5 employees name. The same as this one. Jones, Blake, all the, okay. Here since I've used only the 2 columns, it displays the 2 columns. This is another way of rewriting this query. Now the question is, can I use the subquery, or can I use a join class? So if wherever it is required, you can use join class. Try to avoid using the subquery. Subquery will take longer time. Importantly, when you use correlated subquery. So in this case, this is not a correlated subquery. I'll explain you what is correlated subquery little later. Okay. So that is a rule of thumb. You need to remember it. Try to avoid using. Instead, you can use join class. Okay. Here, I have used the same table more than one time. But in the join class, what I did, I have given the alias as E2. Given the alias as E2. And what I did, I just, I have named this subquery as average sal. So in the join, usually what we do is followed by the join, we specify the table name. Instead of using the table name, we have used the subquery itself. The output of the subquery will be, the output of this one, the average salary will be called as AVG sal. So this kind of a table name. Okay, this table is holding only one value, the average value, and followed by, so whenever you use join, followed by the join, you specify on. So because you are joining 2 tables, right? In this case, we are comparing the, the salary, right? The employee salary, each employee salary is greater than the average salary of all the employees. Okay, this subquery is holding average salary of all the employees. Okay, so here the point which you need to note down is you need to specify the alias name for the aggregation function inside the subquery, and followed by the subquery into use the the name for this table in the case of join. So AVG sal is a kind of a table now. In this table we have a column by the name of sal1. That is what I mentioned here. So E dot salary from the outer query, E dot salary is great. So here what happened, I'm using the outer query's column salary and greater than the inner query's value here, right? So here in this case, what happens? It returns the same output. Okay, both of them produce the same output. So how do I check side by side? You can put go here, followed by the query. And then what you do is select these two queries and execute it together. Click on execute. You will find two windows. You need to keep the cursor somewhere here and then drag this up. You can see Jones, Blake, Clark, Scott, Ford, 2975, 2850, 2450, 3000, 3000. Good. So this is your, this is an example for your scalar subquery. Okay. And also, let's say you wanted to find out all the employees working in the same department as a specific person. Okay. So I just write the problem statement, display all the employees working in the same department as we have someone called Blake, right? Blake. Say, display all the employees working in the same department as Blake. First of all, we need to know which department, or same employees working in the same job. Instead of department, I say no, job as Blake. So in that case, we need to find out Blake belong to which department. Select which what job is he doing it. Select job from employee table where e name is equivalent to Blake. Very simple, this one, and this is my subquery. The outer query is very simple. Select star from employee table. This is very, very simple one, writing SQL query, but it is not as simple as your Power BI, because there you just do the drag and drop, but not all the time we do drag and drop, isn't it? So here, where job is equivalent to display all the employees belong to the Blake's, job or department. So here, let us see any data. Yes, Blake is a manager. Like Blake, how many managers are there, right? So you can say, you can use this one also. But in this case, we have specified the Blake here itself. So now the question is display all the employees whose job is manager. That is pretty simple, right? Select star from employee where job equal to manager. It is simple. But display all the employees whose job is same as Blake's job. So with this, we can understand only 3 managers are there. This is another way of, see, select star from employee where job equal to manager. If you know Blake is a manager, you can simply query this way, like Blake, we can see that, right? 3 managers. It is straightforward. But you do not know what job is holding it. No. These are painful. Hello, who is this? So this is another way of finding out the employees. So this is the one you should be knowing. So once you start practice it, I will give you some assignments. A lot of assignments are there. We start with simple employee department table. Practice it. It's a simple, plain English-like language. Okay, because but one thing. Okay, next one is there any way I can write a nested subquery? Can I write a nested subquery? How do I write a nested subquery? Okay, for example, yeah, so what I'm going to do is see the same thing. Before we jump into the nested subquery, right? What we will do is, let us try this one. Where depart number equal to 30. So is there any other way that I can rewrite it? So where salary is what we will do is, in this case, yeah, where from employee. Yeah, we can use year itself, right? So the where depart number, year itself, we can use this one. Where depart number equal to 30. Where depart number equal to 30. What other things we can do? And salaries greater than this one. Sorry, these two where clauses are there. Now the question is which query is optimal? Whether, see, both of them produce the same output. Okay, which one is optimal here? So ideally, we should have written, the depart number 30 in the where clause of your outer query itself, right? The salary. So what will happen is this one gets executed only once, and then it will go and check, those employees belong to depart number 30 directly. If you have 10 lakh employees are there, what will happen if you use this query? So here it has to find out the average for this depart number 30, and then this one has to again go and filter all the employees whose salary is greater than 30. Instead, if you filter it here itself, and then the output of this one, if you pass it as an pass it to this one as a filtering criteria, this one will be pretty faster. So what we will do is we'll select this one. We have something else called the execution plan. Include actual execution plan, include live query statistics. So we have something called execution plan. I'm going to click on this icon, and then I'm going to execute it again. And 1 second, right? It's not, yeah. So if you wait for some time, I think it should create, yeah, execution plan is there. You can see that execution plan. Something like, the GPS. And if I keep the cursor over here, nested loops, inner join, row, and actual number of rows output. And where is the cost here? We don't see. IO cost is 0. Right? Number of execution, estimate number of execution. Yeah. So we have something called cost. The cost is, let's look at 50% cost. And to execute this, these two queries, it requires 50%. But ideally, if you work with a huge volume of data, you will get to know. Lesser the cost, you keep that in mind. Lesser the cost, better the performance. So whichever query's cost is less. So how do I know that cost? You can see it here itself, right? So once you see the cost, and if it is, for example, if this query's cost is lesser than this, then this one is better. Don't use that query. So this is called your query tuning. Knowing writing SQL query not sufficient. You should know how to do the SQL query. How to rewrite the logic in different ways. So 1 plus 2 is 3. 2 plus 1 is 3. Okay, 1 plus 2 plus, sorry, 1 plus 1, right? So all the three will produce the same answer, but which one is, which one will uh, produce the output in a pretty fast manner, okay? That is what matters. So how do I know that? So you can use the execution plan, enable the execution plan. That icon, you can find it here. Once you click on it, it will get enabled. And then you need to execute it again. And then if you move this up and see that, right, you will find the execution plan. When you click on this, you can see that you need to take a look at the cost. The cost is, let's say, of the two queries. Both the queries produce the same output, but it will give you the cost for each query. For example, the second query's cost is less than the first query. That means your second query is performing better than your first query. This is how you need to answer it in the interview. Okay, if they ask you how did you do the tuning, can you please explain? So you need to tell them, yes, we have so we have a long running SQL query. We just killed it, and then we have rewritten the query, and we have executed those two queries after enabling the execution plan. And then when we just check the execution plan, so the rewritten the SQL query cost was lesser than compared to the previous query. And what we did, we just killed all the things. And once again, we started executing the second query. Second query output, it was producing the output in a pretty fast manner. You can tell that one, okay? Or don't say pretty fast manner. Compared to the previous query, the current query is performance is good, okay? Okay, next one is the nested query, nested subquery. Is there any way can I embed a subquery in another subquery, and can I use that subquery as part of my outer query? Yes, that is also possible. For example, employee name, comma, depart number, comma, salary from employee table where salary is less than, we'll say, less than. Here select average of salary. It's very interesting, isn't it? So you just play around with it, that's all. Employee where let's say where depart number is equivalent to, I'm going to use another subquery. Select depart number from depart table where department name is equivalent to, for example, specific department. My God. Where, so you can use the lowercase for where clause select and all, but this is how you need to write it in practice. Okay, where the name is equivalent to sales. I don't know if sales is available. So this is the this closed parenthesis for this query, and for the outer query we can use another parenthesis. Okay, that's all, and you can select this one and execute it. So in the sales department, what is the average salary drawn? And those employees are getting less than the average salary of your sales department. If you want to see that, you can. Already we have another query. Let me do one thing here. Depart number 30. What was the depart number 30? Let us see. The depart number 30 is something like sorry, this is depart number 30. I'll have to check in the department table. So try all possible combination. The 30 is sales. Yes, it is alternative to that one, right? So depart name equal. This is another way of calling. So here, instead of less than, I will use the greater than thing. This one is a very dynamic one, right? So yeah, depart name equal to sales. Even in the department sales, later point in time, if more employees are joining it, this one will be dynamic, okay? This is an example for your nested subquery. So this subquery is part of this query. And again, this subquery is used for, this subquery, right? This is a subquery. In this subquery, we used another subquery. This is called your nested subquery. And okay, how do I find out the total number of employees in the, so how do you know that? How do you find out? We have something called count function. Okay, count star from, this is not a subquery. And I just check 5. Okay, so total number of employees, sorry, total number of records in a department table is 5. So here, if you want to see that employee table, 14 employees are there, okay? So the same thing, you can use it here, okay? Instead of average salary, count of star from employee or depart number. So you find out how many number of employees salaries, salary is greater than or you can use the count of star here. Okay. Somewhere here you can, yeah, count plus or is salary. Okay. Let us do one thing. We can use count of star here. Here I did not use that one. Okay, count of star. No, only one expression can be specified. Okay, correct, correct. Here you cannot specify more than one expression in the subquery because it's a scalar subquery. Okay, you cannot use it. And now the question is, how do I know? Along with that, I want to display how many number of employees are there in the sales department. Okay, how do I check that one? So probably you can give it a try. Next one is the scalar multi-row subquery. The scalar subquery returns only one value. This is the scalar subquery because it returns average. It computes the average salary on your sales department, which is only one value. Then this is a scalar value. And you have multi-row subquery. Next one is a multi-row subquery. How can I use the multi-row subquery? Using in class, we can do that. Multi-row subquery. Multi-row subquery. Here, what I'm going to do, same thing. Select star from employee. For example, the depart number in, for example, I want to use, what can I do? Okay, select depart number from depart, where depart number is equivalent to sales department, right? Yeah. So display all the employees belong to depart number 30. So in this case, it's a subquery. Okay, and the output of this subquery will be passed, as a filtering criteria for your outer query. So here, if I execute this one, you can see that this query is, even in this query, okay. So, but here, correct. So in this case, okay, in this case, this one returns only one value, right? So it returns only, we cannot say next, we cannot say it's just multi-row subquery. This is also kind of a scalar subquery. And for example, you wanted to display, we can use the in class itself, okay, to get the values. For example, okay, we don't need this in depart number in 10, 20, 30. In class will give you more than one value. So it display 10, 20, 30 related departments, okay? So using in class also, you can filter the data, okay? But here, what we will do is, I have another example here. Okay, the select star from department. Let me see. I'm going to create some scenario. Atlanta and San Jose, St. Louis. Okay. So what I would do is select star from department. Okay. Here, depart number in select depart number where the where department name or a location where location. So here I'm going to use the in class here. Okay. Here I'm going to use Atlanta. Como San Jose. location in this one, right? Yeah. Invalid column name. Why? Where the okay, from, I did not use the from class. From depart table where, yeah. So here it will return more than one row, 30, 40. So let us see what is happening here. So this subquery in this case, it returns more than one row. The output of this multiple row, we will, it uses in the outer query. Okay. So this is called your multi-row subquery. You understand? This subquery is returning more than one value, unlike the previous example. Okay. So hence, this is called your multi-row subquery. And okay, what other things we will look at it? Multi-row nested subquery also we've seen it. Multi-row subquery and scalar subquery we've seen it. Next one is the correlated subquery. What is correlated subquery? It is a subquery that uses values from outer query. That is what your correlated query. Correlated query is try to avoid using the correlated query wherever it is possible, whenever it is possible, because it's very expensive one, the correlated subquery. Okay. So better you avoid using the correlated subquery wherever it is required. Okay. First of all, what is correlated subquery? I will give you one example here. Here, what we will do is, so what is the example here I can give? I can give the same thing, okay? And, okay. For example, you have a scenario like find out all the employees, or sorry, find out the employees. Find out the employees in each department who earn more than the average salary in that department. This is slightly different. Let's say you have a finance department, and finance department 10 people are there, and you have the marketing department there, 20 people are there. You need to find out each department average salary, and then you need to display in each department which implies salaries more than their respective department average salary. Got it? Select star param. This is straightforward one. Okay. Now salary. So this is what we need to filter it, right? Find out the employees in each department who earn more than the average salary in that department. So we need to use the salary column to filter it. Salary is greater than, we need to find out more than the average salary of each department itself. Same query, the average of salary from employee table E2, and here I just say where E2 dot, okay, here we can say the E2 dot depart number is equal to E2 dot depart number. In this case, I have used the, sorry, here E1 dot depart number. Okay, E1 dot depart number. So this E1 is nothing but the outer query. In the outer query, for each and every row of your subquery depends on every row in your outer query. For example, in the outer query, you have 10 lakh records are there. This subquery will get executed 10 lakh times, unlike the plain subquery. In the case of plain subquery, that one will get executed only once. The output of that subquery will be used to filter the outer query. But whereas in this case of correlated subquery, what happens is For each row, it has to take the depart number from the outer query, and then it has to compare it with the subquery's depart number to give this one. Okay, the salaries. Look here, these employees for manager, right? So in the manager, so in the depart number 10, this guy is getting more salary, clerk. Okay, in department 20, these guys scored Scott Jones, right? Within their department's average salary, these guys' salaries are more, 3,000, right? So these are things. So that is what this one tells us. So now you understood what is correlated subquery. So in the case of correlated subquery, the subquery depends on the outer queries column for each and every row. You have to use the outer queries, in this case a depart number, to join this, the inner queries, subquery, everything is same, okay? E2 dot depart number. So only then it will use it. So why depart number, Because this is the common column between, these two tables, right? Employee table. Okay, here the problem statement is this one, right? Within each department, find out the average salary, and in each department you give me those employees salaries are more than their the average salary with respect to their department. This is called your correlate. So what is the difference between subquery and correlate? So the normal subquery is the interview they'll ask you. The normal subquery is executed only once, whereas the correlate subquery is executed multiple times for every row of your subquery. For each row produced by this one will get executed, okay? So it is very expensive. Try to avoid using this one, okay? So what are the limitations of subquery? Next, let us jump into the limitations of subqueries. Subqueries can impact performance, and then you have some nesting limit. You cannot nest, so you have, I think, 32 levels only you can nest. You have seen nested subquery, right? A subquery inside another subquery. Likewise, only up to 32 levels only you can nest it. Beyond that, you cannot do it. So that there is a limitation. So most of the time, the correlate subqueries are inefficient. That is what I told you. Because for each row of your subquery, for each row of your outer query, the subquery will get executed. Whereas in the case of the plain subquery, normal subquery, the subquery will get executed only once, whereas in the case of correlated subquery, the subquery get executed multiple times for each row. Limited reusability. Okay, you cannot, reuse it, as many times as you want it. Okay. Okay, and then okay. Now the question is, so we have some limitations. So what can I do? So can I use any other option in order to overcome writing the correlated subquery? Can try with the join class. Okay, use the join class to replace the correlated subqueries. If you find any correlated subqueries written in your project by someone else, what you do is you take that one and try with the join options. Okay. So joins are sometimes, right, it will be more efficient than using subqueries. Because the optimizer, we have something called optimizer, it handles the joins very efficiently than the correlated subquery. Okay. So in the interview, they ask you can tell them one of my responsibilities, or like, take my peers code. And for example, so here, how many of you joined here? We can see the Aishu and Anwar. Let's say Anwar has written a query, and Aishu, she has written another query. So what they do is once they finish their code, they swap the code. So Aishu code will go to Anwar, Anwar code will go to Aishu. They will review it, and in case of any issues, they will get back. So likewise, you can tell your interviewer. So apart from creating reports and other things, and also my responsibility to review my peers' code. In case of any defects, we find it, and then will get back to the author. Author means who wrote the query, okay, or who created the report or dashboard. So it is their responsibility. So it is their responsibility to do the peer review also after review. So, and then not only your code. So let's say Anwar finds some, problem, bugs in your code, in the Aishwarya's code. So she has to fix it, and vice versa. Okay. So you can tell them that the interviewer, yes, I reviewed my team's SQL queries, and I found there are scenarios where they use these correlated subqueries, and I have rewritten the correlated subqueries, using join class. With that, we could see some kind of improvement in performance. See, they don't recruit you just to do the job, whatever they give it to you. They expect the value from you. What others? See, if I recruit you, people with same experience, they do the same job. Create the report, yeah, create, do the data transformation. But what value you can bring to the table beyond the task given to you? Okay. So that, so that's how, you can tell them. So not only I'm responsible for creating my scripts or queries or reports, at the same time reviewing my team members, script everything, and then finding out, I improve the queries performance, okay, by finding whatever I explain, you can tell the story, okay. Next one, the inline view. So in this case, we can use the subquery from your from class itself, which acts as a virtual table for the duration of the primary SQL statements execution. Okay, so we can do it that way also. The from class itself, we can use it. Okay, for example, what I will do is, instead of using the same thing, yeah, the select statement also we can use it. Yeah, from class we have already seen it, right? One second, the from class. This one, we have seen it already. From average salary from, yeah, in this case, we have used the subquery in the var class. Somewhere I used it. Okay, here we will try the other one. The average salary, I've used it. Okay, and not this one. So this is the one, right? So the same thing. So the from class, we need to specify the table name, or what we'll do is we'll take the same thing. I remove the join here, comma, select as average salary. Okay, we can do it this way also. But in this case, it will throw an error. You are not supposed to use on here. In the specific comma here. Okay, and here we can say the average salary. So there are some cases they wanted to display the average salary across the rows so that you can compare the values side by side. So 1058, this guy is getting it. The average is 1830, so right? So in that kind of situation, you can use the subquery like this, okay? This is called your inline view query. The from class itself, instead of specifying the table, you used a subquery. The output of the subquery is called your virtual table, average salary. Okay, in this thing, you make sure that you are giving an alias here, sal1. So that is what. So this is an example for inline view. You can use the select, you can use in the subquery as part of from class, as part of your var class, and even your select query itself, you can use it. For example, I just use this one here itself. Why to use it in the from class? I will use it here. Produce the same output. Now the question is which one should I use it when? Depends on the query. So that's when you need to evaluate your execution plan. Go to the execution plan and check both the queries, execute both the queries and see the cost. But with the small amount of records, right, you will not find. With the huge volume of data only, you will find the difference between these two. Of these query, whichever queries cost is lesser, that one will be pretty fast. So in this case, the from class you are using it, and then the virtual table and that one. But here you are directly querying it as part of select list. So you can use the subquery as part of the select class. You can use subquery from your from class. You can use the subquery from your where class also. And also we have seen the nested subquery and correlated subquery and the difference between nested and this one you have seen it. Okay. So next one is the group by having class. Okay. Group by having class. Where, oh, sorry, instead of where, I just say group by depart number. Having, I'm going to say average salary. So even in this case also you can use it. Okay, we'll do this one step by step. Here, I'm not going to use the thing here. First, we'll go this with the simple one. So you want to group, so okay, I'll do one thing, email from, but if you use an aggregation function, along with that, if you specify the column, it will not give. So what we do is we will just so it is employee table. Okay, here, let me do one thing. Ename. See here, I did it intentionally. Column employee dot ename is invalid in this selected because it is not contained in neither an aggregated function or the group by. Whenever you see, whenever you use this aggregation function like average sum, right? So usually it will be followed by the group by. So what it does is it does the group by. You remember I explained the group by as part of Power Query editor. Same idea here also applicable, group by. For example, United States, 10 people are there and India, 10 employees are there. You just give me United States, all the 10 employees average salary, all the India employees average salary. Just give me two records. United States, what is the average salary? We are giving it to the employees. India, what is the average salary? So you have multiple records. You need to group the similar records based on the specific columns. In this case, the depart number. All the employees working in depart number 10, you group it and give their average salary. The next one is the second department. So 20. In the 20, depart number 20, give me the average salary. One liner thing, okay? So here, what happens, since this one, okay, what I will do is I'll just use the depart number because in the group by, I have used the depart number column. And with that, if I execute it, it will work. So in the depart number 10, see whatever the column that you specify in the group by, only that column you can specify it along with the aggregated column. That is the rule. You need to remember it. If you specify some other column, employee e-name is there in the employee table, but that is not there in the group by. Hence, it will throw an error. So whatever the group by column that you specify, so the similar values, right? So the depart number 10, take all the employees working in the depart number 10 and find out their average salary. right? That is what is happening. It groups the similar records and then it applies the aggregation. In this case, the aggregation or summarization function is average. So it gives me the average salary in each department here. The next step is, yes, I'm going to find out the average salary. Yeah, so here I don't want to display all the department salary, the average salary. Instead, you display those employees are getting more than their respective department's average salary. Sorry, not the respective department, sorry, overall average salary, okay? So incorrect syntax near employee. So this is employee, right? Here we have used the subquery, hence you need to use the closed parenthesis. Look here. So of these three department put together, in which department the I'll just put the depart number here also. Since we have the depart number, column is available in the group by, we can use it here. So yeah, in the depart number 20, that employees in the department, see, we have three departments, 10, 20, 30. Of the three department, which department employees are getting the salary which is more than the overall employees average salary? This is the one you get it. So group by. So now the question is, what is having class? So like where class, we select followed by where you can use it. You can either use it or you don't have to use it, but usually we'll be using where class followed with the select statement. The reason is you want to filter the data and then only you want to work on it, okay? But in this case, I did not use where class. It is not required. Simply use the group by. And now I want to apply the filter on the grouped records. See, this one have the output something like 10, 20, 30. But again, I'm defining additional condition here. Of these three groups, you tell me which groups average salaries, which department, right? In which department or which group salary is more than the average salary of overall employees. So the depart number 20. Okay. So that is what we can see that here. So having class is nothing but applying a filter on your grouped records. Fine. So now you have learned what is this one. Next one is the set operators. What you do is you can watch my video. It is already there. It's very simple one. Union, school time, we studied. Union, all the things, right? So I'm going to skip that topic. And even joins also, I'm going to skip it because joins I covered again extensively in the Power BI. The same idea here, okay? Next one is, so this is the interview question. This is the important thing. What is the difference between intersect and join class? They will ask you this one. The interview, they'll ask you, what is the difference between intersect and what is intersect? School time is the common value between the two tables, right? What is inner join? What is inner join? The common value between the two data set. So then what exact difference exists between these two things, intersect and this one? The intersect will give you the common value between the two data sets. Fine. For example, select depart number. Look here. I just go here. Select star from depart. If I say same thing, and here I just select only the depart number. Here we can see that 5 records are there, 5 departments are there. And what I do is depart number. We have something called intersect operator. Intersect, select depart number. from employee. So the common values are 10, 20, 30. But actually, we have how many departments? 5 departments, 10, 20, 30, 40, 50. So with that, you can understand 40 and 50, we did not assign any employees so far. Okay, the common values. The same thing is if you want to use the join, inner join from department, and here you need to specify join, inner join on the employee table. Whenever you use join, right, inner join, outer join, you need to use the on class, because you remember one thing very clearly: whenever you join more than one table, you have to specify the common column exists between the two tables. So here, so I just give some alias here. So department is D, sorry, here D, and the employee is E. Instead of typing the full name of the table here in the on class, D dot depart number, and here E dot depart number. These are the two columns common between these two tables. So here it gives me 20, 30. Okay, but here what is happening is so unlike this one, right? So it gives me all the employees that work for the depart numbers that are there in the department table and employee table. So 10, 20, 30, right? It returns multiple rows. So, okay. So this is the difference between the intersect and joins, okay? And next one is we have something else called cross join. Cross join. For example, here, the cross join is very expensive one. Don't ever use it. But there are scenarios you can use it. For example, you have something like, see, if I don't specify on, what will happen? If you don't specify the common column exists between these two tables, what will happen? It is doing the cross join. Cartesian join. School time you studied the Cartesian join, right? The same thing is going to happen here. I just remove this one. It is not required. Inner join. Okay, but here it will go by the syntax. The employee table. Okay, on, is not there. Okay, what I will do is I'll just say simply comma. And here the department, D, yeah. Here I say D, and here I say E. E dot E name, comma, D dot D name. Okay. But here I did not specify on class. Okay. But you need to specify, look here, Cartesian join is happening. What is a Cartesian join? I will just write it with simple example. For example, you have, car example. Okay. You're a dealer for selling cars. And, let's say you have something called Mahindra. This is a brand name, Mahindra car. And model is XUV. Similarly, you have something called Mahindra, and you have something called TV100, right? Something like that. And MG Hector is another car. Listen, this is something like MG100, something like that. Okay. This is your one table data, and you have another table. Okay. In the another table, you have something called the color ID and color name. Here, let's the color name is color ID is or color ID. Okay, 1, 2, 3, something. Color name is red, blue, ash green, something like that. Okay. So what the situation is, each model you sell all the three colors of the cars. Even here. So Mahindra XUV, red, blue, ash green you select. TV100 also you said you have three different colors available. Even here also you have three different colors available. In that case, what we do is select the column name, column 1, comma, column 2 from table 1, table 2, cross join. We have a reserved word called cross join. The cross join, what we do is here, so what we will do is, in this case, sorry, not table 2. This is car, right? Okay, I'll just write it car, and this is color. Okay, as CL or something like that. So what will happen is, it goes for each and every record. This is called your Cartesian join. Every record in a table is joined with every other record in another table. That is called your Cartesian join. This one you should be knowing it because school time they explain you, right? Cartesian join. The Cartesian join is very expensive, hence try to avoid using this one. If you don't use the, look here, in this case, I did not use the on class, right? The common column in the where class, I should have specified where department D dot depart number equal to E dot depart number. I did not specify it. Hence, it is doing the Cartesian join. If you don't specify the common column exists between the two tables in the where clause or inner join using on, it will do the Cartesian join. But here it is not required, Cartesian join, whereas in this case it is required. So there are some situations you can do the cross join, but in general, cross join, we don't use it at all. Rarely we will be using it, like this example which I explained you, okay? What is Cartesian join? They may ask you in the interview. Cartesian joins or the cross join. Cross joins are nothing but every record in a table A. For example, I have table A, table B. Every record in table A will get mapped with every other record in table B. It will select the values from table B. Okay, and again, the same thing will happen for the second record till the end of your table A's record. It goes and select all the records from the second table. That is called your cross join. It is also called as a Cartesian join. Okay. What is that? Next one is self join. Self join. Self join. You can do it. So when can I use the self join? So that is what the question from Raji. See, what you do is self join is nothing but joining the table to itself. For example, e dot e name from employee table, and here comma listen on e dot mgr. Okay, I'm going to say as manager. From employee, left join e dot depart number, sorry, e dot emp number on, sorry, left join here. You need to specify this thing. Okay, here I just say employee E1, employee E2. On e dot E1 dot emp number is equivalent to E2 dot emp number. This is E1. Whatever the alias, the short name that you use it for it, that is the one you need to use it. Otherwise, it will not work. Here, yeah, we have something called MGR column, I believe. Here, what I am going to do is, even dot MGR comma, even dot ini. In this case, I'm using employee table only. Yeah, so here I put extra comma. Ward Jones Martin. Okay, there is something wrong here. Mode filler. Here it is not this one. Sorry, you need to use the MGR here. Even dot. Sorry. Employee number is the right employee number. And yeah, so here let us do one thing. Let us select the table name. Select star from employee table. So here, if you see the data set, the employee number is 7369 for Smith. And we have a column called manager. Here also they mentioned the employee number, but this employee number is nothing but the Smith's manager's employee number is 7902. Where is 7902? This is the one. So Ford, right? Ideally, it should display the employee name as Ford here. Left join E2, right? So here I should have mentioned E2 and E2 dot MGR. It is, yeah, we have some null is there, which means, Smith, it is not showing anything. And Jones, okay, here, what I will do is, okay, for Jones, the manager is Scott, and the Jones is also reporting to another manager. Okay, that is what it shows here. Okay, let me do one thing here. Even dot name. And even dot manager, right? So the manager ID, and then the E2 dot ename. Okay, so okay, this is employee E1, the employee E2, correct? On employee, yeah, even dot employee number. Okay, in this case, I did it in the other way around. What I will do is yeah, it's correct only. Even dot emp number is equivalent to E2 dot MGR. The left join is the reason why we are using, look here, this one gives me, the inner join gives me the correct thing. For Ford, the manager is Smith, and for Blake, Allen, and again, Blake is reporting to, more than two guys, right? So Allen and Ward and Martin, and whereas King is Jones, and yeah, we don't see null here. I think, yeah, Blake's manager is Turner, okay? Blake's manager is Turner. So this is your self-join. You are joining the same table to itself. Look here, employee and employee. You are joining these two tables by itself, okay? So the left join, you can use the left join here. The left join, what it does is, it will show you whatever the employees are there here, which are not there. So whichever employees, they don't have manager. Look here, Smith, he doesn't have manager, okay? Right, he doesn't have, maybe these guys are vice president or someone in the company, they are not reporting to anyone, but Scott is reporting to Jones. And where is Smith? Can we see Smith record? Smith, Allen, and what? King, Scott. Okay, these three guys may be right, they are not reporting anyone, but Jones, he's the one reporting to Scott and Ford, and Blake is reporting to these guys, and King is reporting to Clark, and so on. But there are some keys are missing here. The manager, maybe, right, these guys are not reporting, but here it shows the Jones, Blake, Clark. There is something wrong with the data. Turner, and James, right? So yeah, better you can use inner join here. You are joining the same table to itself, right? So that is what you can say. That is what is called as a self join. The outer join, left join, everything we have already discussed, right? As part of the Power Query Editor, you can try the same thing. Okay. The next one is the except. It returns only distinct that happens in the first set, but not the second. Okay, except the same thing. For example, here the same example, depart number. Instead of intersect, we are going to use the except. Whatever the department number that are there in my department table, which is not there in my employee table, give me that. What are the output? What is the output now? The 40 and 50. And you can change the order of this query also. You can put, this one here. And you can copy this and then you can put it here. In this case, it will not give anything. All the department number that are there in the employee table, it is there. And there is no difference, except it's kind of a minus, A minus B. So here, 30, 40. You know very well, in department table, we have 5 department, 10, 20, 30, 40, 50. But in the employee table, depart number column, we can see only 10, 20, 30. Now the question is, what are the department number that are there here, which is not there in the employee table, which is 40, 50, right? That is what it gives us. Except is kind of minus operator. Intersect minus union operator, you can try it very simple one. Union and intersect and except, right? Fine. The next one is group by. So what we'll do is in tomorrow's session, we'll take a look at the advanced analytics, so advanced queries.